XAI team was there to unveil Grok 4. This is the latest artificial intelligence system.
Scientists have spent 140 years studying Earth's climate cycles. They were certain they understood what they were looking at. Then Grok AI ran the numbers, and Earth's climate history suddenly looked less like science and more like a blueprint. The pattern was too consistent, too deliberate to dismiss as random natural occurrence. The scientist who reviewed the findings went quiet, because whatever left this pattern behind was not reacting to Earth. It was controlling it. So the question is no longer whether the pattern is real. The question is who or what has been controlling it all along. The first reconstruction. The first major warning sign appeared when Grok compared two climate events that should have had nothing in common. The first was the Paleocene-Eocene thermal maximum, a violent global heating event that occurred 56 million years ago. During this event, massive volcanic activity released enormous amounts of carbon into the atmosphere. The oceans turned acidic, deep-sea species collapsed. Global temperatures rose by several degrees in a short geological interval, making large regions nearly unlivable. Grok then examined the late Pleistocene warmings, which took place during the end of the last ice age within the past 100,000 years. A warming in this context means a period when Earth's average temperature rises rapidly, instead of slowly shifting over thousands of years. During these episodes, the ice sheets covering North America and Eurasia fractured, and released sudden floods known as meltwater pulses that raise sea levels at terrifying speed. Coastlines drowned, entire valleys vanished underwater. Many large animals such as mammoths, giant ground sloths, saber-toothed cats and woolly rhinoceroses disappeared in what appeared to be a chain reaction of starvation, habitat loss, and sudden climate shock. Some regions experienced temperature jumps within a human lifetime, forcing early humans to abandon their lands as storms intensified. Food chains broke apart, and environments shifted faster than any society could adapt. These two events came from completely different causes. The ancient heating was driven by volcanic carbon release from huge eruptive zones called flood basalts. These eruptions pumped so much carbon into the atmosphere that the planet entered a runaway heating phase. In contrast, the Ice Age warmings were triggered by changes in Earth's orbit that altered how much sunlight reached the surface. Scientists had always assumed these events were unrelated because their triggers were so different. But Grok revealed something that overturned that belief. After processing millions of data points from both events, the AI rebuilt the temperature history of each one step by step. For the Paleocene-Eocene event, Grok began by feeding in temperature data extracted from ocean sediment cores, which contained chemical markers showing how warm the water was when ancient microorganisms lived. It combined these with carbon isotope records that reveal how much carbon entered the atmosphere. For the late Pleistocene warmings, Grok used ice core data showing past temperatures, greenhouse gas levels, and dust concentrations. It also used ocean sediment records that track water temperature and meltwater pulses released when the ice sheets broke apart. Each dataset created a continuous timeline showing how fast or slow the planet heated during each period. Grok then converted these timelines into temperature curves. A temperature curve is a line that shows how quickly the planet warmed over time. The AI set both curves on the same scale, meaning it matched the years, the temperature units, and aligned the starting point so the comparison would be exact. This allowed the team to see not just the beginning and end of each warming, but the entire shape of the heating process. Once the curves were aligned, something shocking happened. In both events, the warming began with a gentle rise. After that rise, both curves bent sharply upward at the same point, meaning the rapid heating phase began after the same amount of time. Both curves then climbed at nearly the same speed, showing that the planet heated at the same rate even though the triggers were completely different. Both showed warming rates between 0.02 and 0.03 degrees Celsius per century during the rapid acceleration phase. Finally, both curves flattened at almost the same temperature level, marking the point where the heating stopped. When Grok placed the two curves directly on top of each other, their outlines nearly erased each other. All four phases matched between the two events, even though they occurred 55 million years apart. Several researchers froze when they saw the display. Two events driven by completely different forces were following the same step-by-step pattern, with the same timing and the same limits. It looked less like random climate behaviour and more like the planet was following a preset sequence. The The match was far too tight to be a coincidence. This forced Grok to ask a deeper question. It needed to find out whether these repeating signals were regional events or signs of a global pattern. The system began its search with the most violent moments in Earth's history. It turned toward the extinction events themselves. The 5 mass extinctions. The first scene Grok revealed was the Ordovician-Silurian extinction, a catastrophe triggered by a sudden global freeze. This freeze began when massive volcanic eruptions deposited huge amounts of rock and ash that increased the rate of weathering on land. That weathering pulled carbon dioxide out of the atmosphere much faster than normal, which caused the planet to cool sharply. Nearly 85% of marine life vanished. Grok shifted to the late Devonian extinction, a long crisis pushed forward by repeated environmental shocks. Expanding land plants released nutrients into rivers. These nutrients washed into the oceans and created large dead zones where oxygen disappeared. Coral reefs collapsed. River systems turned stagnant and toxic. Giant armoured fish, such as Dunkleosteus, vanished. About 75% of species were lost. The room grew tense when Grok opened the end Permian extinction, the Great Dying. This collapse was driven by massive volcanic eruptions in Siberia that released enormous volumes of carbon dioxide, methane and sulfur gases. Forests burned, the oceans turned acidic. Up to 96% of marine species died. Many early reptile and amphibian groups disappeared. The AI then examined the end Triassic extinction, which began when violent volcanic eruptions tore open massive rift zones across the planet. These eruptions released huge amounts of carbon dioxide and toxic gases into the atmosphere, driving rapid warming and triggering one of the most destructive collapses in Earth's history. Finally, Grok reached the Cretaceous-Paleogene extinction. A large asteroid struck near the Yucatan Peninsula. Shockwaves, fires, and global darkness followed. Dust and toxic gases filled the sky. Non-avian dinosaurs vanished. 75% of species died. Only after showing all 5 disasters did Grok reveal the part that stunned the room. When the AI stripped away the differences between each extinction and kept only the physical signals behind them, the same hidden structure appeared every time. It did not matter whether the collapse began with freezing volcanic eruptions, asteroid impacts, or slow climate swings. Once the planet was pushed past its first critical point, it entered the same chain reaction. The first stage always began with a sharp rise in greenhouse gases, which are heat-trapping gases in the air such as carbon dioxide and methane. Grok showed that each extinction crossed this rise at nearly the same proportional rate, even when the original trigger was completely different. This pushed global temperatures upwards so quickly that ecosystems could not adjust. The second stage appeared when the oceans lost their ability to mix. Grok displayed oxygen maps from different eras and showed the same pattern forming again and again. Warm water stayed at the surface. Cold water stayed trapped below. Oxygen stopped circulating. Huge sections of the ocean turned deadly in the same way across every extinction, even though the continents and sea levels were never the same. The third stage emerged when the final temperature surge hit. Grok highlighted the same steep climb in every dataset. Once this surge began, ecosystems already weakened by heat and oxygen loss collapsed in a rapid chain failure. Forests, food webs, and entire species groups unraveled at nearly identical points on the curve. The room went silent because Grok had shown something no human had ever proved before. Earth did not unravel differently each time it was stressed. It broke in the same order, through the same stages, as if the planet were running a script that reactivated whenever conditions crossed the same invisible threshold. Grok then exposed a disturbing timing pattern that strengthened the feeling that something was wrong. 4 of the 5 mass extinctions occurred within a narrow window of 145 to 155 million years apart. This tight spacing was not normal. Events driven by deep Earth processes, such as mantle plumes, rarely behave with such precision. Mantle plumes are rising columns of extremely hot rock that can cause long-lasting volcanic activity. Their eruptions usually vary by tens of millions of years. Grok showed that the extinctions did not drift in timing the way mantle plume events normally do. Instead, they aligned far more closely than expected, which meant there was a consistency in the collapse intervals that natural geological behaviour could not easily explain. Another detail made the entire team uneasy. Grok compared the end Permian and end Triassic extinctions. These disasters happened during very different continental arrangements. During the end Permian, all of Earth's land masses were joined together into one giant continent called Pangaea. Every major continent was connected as a single land block with one enormous coastline. By the time of the end Triassic, this giant continent had begun to split. New cracks opened in the land. Ocean water filled these rifts. The single landmass started dividing into separate pieces that would eventually form the modern continents. Even with these major differences in Earth's layout, the atmosphere in both eras reached almost the same buildup of sulfur aerosols. Sulfur aerosols are tiny particles produced by massive volcanic eruptions. They rise into the atmosphere, reflect sunlight away from the surface and disrupt climate. At first they cool the planet, but the cooling is temporary and often followed by long-term instability. Grok calculated that the concentration of sulfur particles before each collapse reached levels high enough to block sunlight over large regions of the planet. The fact that both extinctions reached nearly identical sulfur levels suggested that Earth crossed the same dangerous atmospheric threshold, even though the continents were arranged in completely different shapes. This meant the trigger could not have come from the layout of the land itself. Something was acting on the whole planet in the same way at two very different points in history, which made the team question whether these collapses were natural at all. This repeating structure and timing forced the team to consider whether forces beyond Earth's interior were influencing the cycle. Orbital and axial cycles. The team expected Earth's orbital movements to complicate the reconstruction. These movements change slowly over very long periods and alter how much sunlight the planet receives. Scientists call them Milankovitch cycles. They usually treat these cycles as gentle background factors because they shift so gradually that they are not expected to create sharp or precise climate changes. Grok began with the first cycle, eccentricity. This cycle measures how Earth's orbit changes shape over time. Earth does not travel around the Sun in a perfect circle. The orbit sometimes becomes slightly more rounded and sometimes becomes slightly more stretched into an oval. This change happens because of the gravitational pull from other planets, especially Jupiter and Saturn, which tug on Earth's orbit over about 100,000 years. Grok then matched this orbital cycle with temperature records from ice cores and ocean sediments. These records act like timelines showing when Earth was warm or cold in the past. Once Grok placed these two datasets together, the pattern became easy to see. Whenever Earth moved out of an ice age and into a warmer period, the warming always began during the same specific section of the eccentricity cycle. An ice age ends when the planet starts warming quickly, and Grok showed that this warming always began when Earth's orbit reached a particular shape within the eccentricity cycle. That shape allowed a slightly stronger amount of sunlight to reach the planet, and when the sunlight crossed a certain level, the ice sheets began collapsing. Climate research has identified this critical threshold. When summer sunlight at 65 degrees north latitude exceeded approximately 460 watts per square meter, deglaciation consistently began within centuries. Grok then showed what happened next. During these transitions, the massive ice sheets covering large parts of North America and Eurasia weakened at the exact same sunlight level each time. Once that threshold was crossed, the ice cracked and thinned rapidly, and melting accelerated. What shocked the team was not the melting itself, it was the precision. Ice ages ended at almost the exact same orbital moment every time, even though each ice age had different temperatures, different amounts of ice, and different ocean conditions. Earth was not warming at random. Earth was reacting at the same trigger point again and again. To find out whether life followed this same repeating rhythm, Grok turned to fossil records across multiple continents. Fossil records show ecological resets that match a repeating climate rhythm. Fossils come from different continents, different time periods, and completely different environments. If anything in Earth's history should have looked random, it was the rise and fall of species. Instead, the moment Grok began stitching the fossil data together, the pattern on the screen stunned the researchers. Grok began with North America's marine fossil record. During the late Ordovician extinction, brachiopod diversity dropped by approximately 60% within less than 1 million years. This decline coincided precisely with the first major glacial pulse. The fossil record shows no gradual decline. Species that had persisted for tens of millions of years simply vanished from the sedimentary record. Within 2 million years after ice sheets retreated and temperatures stabilized, New brachiopod genera diversified rapidly to fill the vacant ecological roles. Right after each collapse, new species appeared and spread. Grok placed all of this on a timeline and compared it to the climate cycles it had already uncovered. The timing matched perfectly. The die-off always happened shortly after the climate changed, and the recovery always began once temperatures settled again. It was fast. It was repeated. It was not random at all. Europe told a similar story, but this time on land. Fossils showed that large forests filled with oaks and pines disappeared suddenly and were replaced by wide grasslands. These changes did not take millions of years. They happened within short periods right after temperatures rose. Grok showed that once the climate became warm enough, the trees could no longer survive. Drier conditions and hotter summers killed off the forests, and grasses which grow faster and need less water took over almost immediately. Grok displayed two timelines on the screen. One showed the temperature rising, the other showed the vegetation changing. The moment the temperature crossed the critical point, the forest collapsed and grasslands spread. The lines matched so closely that several researchers froze in place, staring at the screen in disbelief. Africa delivered an even more unsettling reveal. Grok examined fossil sites, stone tool layers, and ancient DNA taken from early human remains. These records show when human populations grew, shrank, or suddenly moved into new regions. Grok compared these population changes to precession, which is the slow wobble of Earth's axis that repeats every 19 to 23,000 years. When the AI lined up the two records, the match was immediate. Human population growth always accelerated during the same part of the precession cycle. This happened when rainfall increased across East Africa and created large lake systems. When the climate shifted back to dry conditions during the opposite part of the cycle, populations collapsed or moved away. The AI displayed these wet and dry cycles beside human population changes, and the lines rose and fell together in a way no one expected. Then Grok reached the Toba supereruption, which erupted in Indonesia about 74,000 years ago. The volcano blasted ash across much of the planet and released so much sulfur into the atmosphere that sunlight dropped sharply. Temperatures fell fast. Many human groups were wiped out completely. Genetic studies show that the global population dropped to only a few thousand survivors. Grok showed how this collapse matched the same biological pattern seen in earlier African crashes. The population dropped shortly after a climate shift, reached a low point, then began growing only when rainfall increased again. The most disturbing part came next. Grok analysed earlier human expansions out of Africa. These expansions mean the moments when early humans spread into the Middle East, Europe and Asia. Grok discovered that these movements did not happen at random. They occurred during nearly the same points in the precession cycle every time. Each expansion started when East Africa entered a wet phase, lakes expanded, vegetation grew, and food became abundant. Once these conditions appeared, humans moved north in large numbers. When the climate shifted back to dry conditions, the movement stopped. Grok placed the timelines together. Human population growth, collapse, migration and recovery all followed the same repeating rhythm. It did not matter if the trigger was normal climate change or a catastrophic eruption. The pattern returned again and again with the same timing. It no longer looked like early humans were reacting freely to their environment. It looked as if the environment was pushing them in the same direction at the same points in time. Everything the AI found so far pointed in one direction. Earth's climate and life were repeating the same rhythm across hundreds of thousands of years, but the pattern still needed a final test. To see whether this hidden rhythm held up under the harshest conditions on Earth, Grok turned to the one place that records every major climate shift without fail: Antarctica. Antarctica shows the same climate trigger, repeating across deep time. The first data came from fossil pollen trapped in ancient sediments. These tiny grains proved that Antarctica once supported warm forests. Some of the pollen came from flowering trees and shrubs that cannot survive freezing temperatures. Grok dated the last appearance of these forests to about 35 million years ago and placed this information beside global carbon dioxide levels from that time. No one predicted what came next. The forests vanished the moment carbon dioxide reached a narrow band between 400 and 500 parts per million. Grok then moved to sediment cores taken from the Ross Sea and the Weddell Sea. These are long tubes of mud pulled from the seafloor, and each layer inside them shows how much ice covered Antarctica at different points in time. Grok discovered that whenever carbon dioxide dropped below the same 400 to 500 parts per million range, the Antarctic ice sheet began to grow at remarkable speed. The growth did not unfold slowly. It began the moment the planet passed this carbon dioxide limit. Grok showed the first sign in the record, which was cooling. Cooling means the average temperature of the region dropped quickly. As the air and water became colder, sea ice started forming across the Southern Ocean. This new sea ice spread fast because cold conditions allow ice to grow outward instead of melting back. The next step shocked the team because it repeated every time. Ocean circulation slowed. Under normal conditions, warm water rises and cold water sinks, which keeps the ocean moving. When the surface becomes extremely cold, it forms a thick layer that acts like a lid. This lid stops warm water from rising, so the ocean becomes still. Once the ocean stops mixing, it loses heat even faster. Because the warm water is trapped below and the cold surface keeps getting colder, the entire region cools sharply. This temperature drop creates the final step. The Antarctic ice sheet surges outward. The thick ice grows across the continent and pushes into the ocean. Grok showed that this entire chain of events happened not once or twice, but in multiple eras, millions of years apart, always following the same steps in the same order. Next, the AI examined oxygen isotope data from tiny ocean organisms called foraminifera. These organisms build shells that change depending on how cold the water was when they lived. Because the shells hold this information, scientists can use them to measure past ocean temperatures with surprising accuracy. Grok placed this temperature record beside its reconstruction of Antarctic ice growth. The two lines matched with frightening precision. Every glacial expansion began after the same sequence of cooling, sea ice buildup, ocean slowdown, and global temperature drop. What shocked the team most was how often this sequence appeared, even when the planet was arranged in completely different ways. During the Eocene period, more than 30 million years ago, Antarctica was closer to Australia and South America. Sea levels were much higher, and the ocean pathways between continents were wider. During the Pleistocene period, which includes the last ice ages, the continents were in their modern positions and land bridges had formed in some areas. Even with these enormous differences in geography and ocean flow, the ice still grew when carbon dioxide fell into the same narrow range. This meant the continent did not react based on where the land was or how the oceans moved. It reacted only when the climate reached a specific trigger point, and it did so in the same way across millions of years. The next question was unavoidable. If Earth keeps repeating these patterns, what exactly is enforcing them? Grok was finally ready to answer that. Grok reveals the system behind the pattern, and the next reset has already begun. Grok began its final test by wiping the screen clean. It displayed no charts and no long timelines. It simply asked whether Earth behaved like a free natural system or something operating under fixed rules. The team waited for another reconstruction, but Grok did not show one. Instead, it showed a new dataset the researchers had never combined before. It was a set of trigger points. These were exact conditions that appeared every time the planet shifted into a new climate state. Grok explained that if these triggers lined up in the same order across unrelated eras, then Earth was not responding freely. It was being pushed by a deeper structure. Grok then exposed what that structure was. It was not a single force, it was not a conscious design. It was a network of processes that had locked together so tightly over geologic time that they behaved like a regulating machine. The AI identified the key components: silicate weathering pulling CO2 from the atmosphere when temperatures rise, ice albedo feedback where melting ice exposes darker surfaces that absorb more heat, ocean circulation changes that redistribute warmth globally, and the carbon cycle where warming oceans release dissolved CO2 back into the atmosphere. The AI identified the components one by one. When carbon dioxide climbed too high, rock weathering accelerated and pulled it back down faster. When the oceans became too warm, deep water circulation changed and forced heat back into the air. When ice expanded, it reflected so much sunlight that global cooling increased automatically. When the planet cooled too far, the oceans released stored carbon dioxide and drove temperatures upward again. Each of these reactions existed for natural reasons, but Grok showed that when they interacted, they formed something new. The system acted like a mechanism that corrected the planet whenever it crossed specific limits. Someone asked what kind of mechanism it resembled. Grok answered by comparing the climate system to devices used in engineering. It said the pattern matched a threshold controller. which is a machine that activates different responses when a system moves too far in one direction. It explained that this type of machine watches a system closely and waits for a specific limit to be crossed. Once that limit is passed, the machine reacts immediately and forces the system back into a safer range. Grok then showed that Earth's climate worked in the same way. When carbon dioxide rose too high, when the ocean stored too much heat, or when the ice sheets weakened past a critical point, the planet reacted right away. The reactions always switched on in the same order. They always had the same intensity. They always appeared at the same points in Earth's history. Grok said this kind of strict repeated behaviour is exactly what threshold controllers are designed to do in engineered systems. Then came the part that froze the room. Grok revealed that the regulator, which was the name it used for the combined climate processes that acted together like one unit, did not only correct the climate, it periodically cleared the entire biosphere. The AI then showed collapse curves taken from many extinction periods. These curves were simple graphs that tracked how quickly ecosystems died once the regulator activated what Grok called its final response, which is the point where the climate system stops trying to stabilize and instead forces a full reset. The curves all had the same steep drop. They showed life collapsing at almost the same speed and following the same sharp downward shape every time. Grok explained that this shape only appears when a system has been pushed past its absolute limit and is resetting itself from the bottom. To make this clear, Grok compared the curve to the kind seen in engineered systems like emergency shutdowns in reactors or overloaded power grids. In those systems, once the threshold is crossed, everything shuts down in a rapid, controlled crash, so the machine does not destroy itself. That was the moment the team understood the real message. Earth's climate system behaved the same way. Once the final limit was crossed, the regulator did not soften the impact. It triggered a collapse designed to wipe the slate clean. Only then did Grok reveal why the pattern appeared artificial. In nature, systems do not keep the same limits over hundreds of millions of years. They do not reset themselves at exactly the same points in time. They do not collapse at the same speed every time. But a regulating structure does behave this way. Grok AI finally revealed the reason behind this. Earth had accidentally created such a structure. It happened because the planet's feedback mechanisms gradually became more connected and more tightly linked. These feedbacks are processes where one action causes a reaction that loops back to influence the original action. For example, when temperatures rise, ice melts. As the ice disappears, less sunlight is reflected and more heat is absorbed, which then causes further warming. Over time, these kinds of feedbacks in Earth systems became so tightly linked that they started functioning as a single unit. The planet began to act like a machine that enforces its own limits to stay within safe conditions. Then Grok displayed the final frame. It showed the current state of the cycle. Carbon dioxide levels were rising toward the same limits that had triggered collapses in the past. The oceans were heating at nearly the same rate observed before earlier resets. Ice was melting at the same points in the cycle where instability had previously begun. Grok then highlighted a line marking the next critical threshold. The present day appeared almost directly on top of that line. This meant the conditions that triggered collapse were returning. Grok concluded that Earth had already entered the early stage of the next reset. Make sure to click the cards on the screen now for more interesting videos.